Hello and welcome to the Unit 3 Complex Numbers review for the test. This is part 1, which will go through the first 4 or 5 questions, and then part 2 will be through the rest of the exam review. So if you feel comfortable in these first couple questions, you can skip or you can go to the next video, whatever you'd like. With number 1, finding all solutions to the equation. That all solutions is actually key because in all of these are squareds, and so in order to get a all by itself, to get rid of that square on it, we have to square root it. But there is multiple options. There's the positive option and the negative option. So a could be equal to the square root of the positive square root of 1, which is just 1, or it could be equal to the negative square root of 1. And you can also just write this as just plus or minus 1. That's because -1 times -1 will still equal a positive 1 when you square it, and you also have +1 times +1 will equal +1. Second one, square root both sides because you're inserting that square root into the problem. You have the option of positive or negative, and square root of 13 is not something that can break down, and I'll explain what I mean by that later in the quadratic formula problems. So you just are going to have the positive or the negative square root of 13 on c squared equals -9. Because it's a negative on the inside of the square root, that is going to break down to the positive or negative square root of 1 and 9. And I'm actually going to switch these because we have the positive or the negative. And then the square root of 9 is going to be 3. And the square root of -1 is the imaginary number I. And for the last one, square rooting, remember the positive or the negative. Square root of 5 is not a perfect square. So because of that negative, you are going to have I to come out, and then the square root of 5. On number 2, you're kind of going to treat I like a variable in the sense that you're going to combine like terms. So if it has an I, if you're adding or subtracting it, if it has an I, you can combine those. If it doesn't, don't combine them. So 3 minus 5, those are real numbers. So that's going to be -2. And then you can do 9 minus -3. And so 9i minus -3i. That'll be a positive, turn into a positive. So this will be plus 12i. On the next one, you're adding them. So 7 plus 3, that'll be 10. And then you'll have 2i plus -2i, which will be 0i. So this final answer is just 10, the real number 10. And then when you are multiplying them, I'm going to show this in kind of 2 ways just because the visualization is good to see. So 2 times 4 is 8, and then you're going to do 2 times 7i. So when you're multiplying, you can multiply not like terms because you're just multiplying by that amount. So 2 times 7i is going to be 14i. And then -2i times 4 will be -8i. And -2i times 7i will be a -14i squared. So when you're multiplying an I times an I, that gives you an I squared. And I'm also going to do that in the box method just because some students like to see it in the box method when you're multiplying. And this method also is the backwards version of factoring. So multiplying 2 minus 2i and 4 plus 7i, you're going to get the same numbers. 2 times 4 is 8. Then we get -8i. And then we get 14i. And then we get -14i squared. Okay, so then I squared is a -1. So wherever you see an I squared, and I forgot to put the squared there, wherever you see an I squared, you will replace that with a -1. So this is going to be 8 plus 6i, so 14i minus 8i is 6i. And then this will be -14 times -1, which will turn into a positive 14. Which then you can combine to be 22 plus 6i. So if you're struggling on remembering that fact, the I squared turns into the -1, or just combining all your like terms down to get to the a plus bi form of the complex number, make sure you practice those. And then here on this one, I kind of just would go through and find the value of each of these. So I squared is going to be -1 times 3 plus I, which is going to be -3 minus I. And that way you can match them after you're done with the correct one. So -4I times 5I will be -20I squared, which I squared is -1, so this will be a positive 20. Then we'll have 5I times 4 is 20I, and 5I times -3I will be -15I squared. So this will be a positive 15 plus 20I if you put it in the standard form. This one I'm going to change that color to be -1, 1 times -1, then 1 times 3I will be 3I, then 2I times -1 will be -2I, then 2I times 3I will be plus 6I squared. That I squared will turn into a -6I squared will turn into a -6. So we'll have -1 plus I. So you'll end up getting -7 plus I. Wrote that all wrong. -7 plus I. Okay, so on the other side, to match them up, this first one will be, since they're subtracting in the middle, watch what they're doing in the middle. 3 minus 10, so that'll be -7. And then 5I minus 4I will be plus I. So these two will match. And then these two are multiplying, so we'll get 4. 2 times 2 is 4. 2 times -4I will be -8I. Then this will be 4I times 2, which will be plus 8I, so those two will cancel. And then 4I times -4I will be -16I squared. So this will turn into a 4 plus 16, which will be 20. On the next one, these two are adding in the middle, so we'll have 1 plus -4 will be -3. And then -4I plus 3I will be -I. So this will match with the first one on the left side. And then obviously, hopefully, these last ones match, but just check it. -6 minus -21 will be -6 plus 21, so that'll be 15. And then 12I minus -8I will be 12I plus 8I, so this will be a plus 20I. And then rewriting these each in the complex standard form, the A plus BI form. I'm going to skip A and B since there's examples above of that. C, though, you got to take this cube to each number or I inside because they're not adding or subtracting on the inside. So this will be 3 cubed times I cubed. 3 cubed is 27. I cubed, though, and I'll talk about this on the next page, is going to be -I. So this will be -27I. And then on D, there's examples above of that. But E, you can multiply the numbers. So this will be 3 times -2, which is -6 times 4. So this will be -24. And then you have 3 i's multiplying by each other. So this will be I cubed. So then again, you have -24 times -I, which ends up being a positive 24I. And with the powers of I on the next page, we have to remember that the square root of -1 is I, so I is equal to I. So I squared will be the square root of -1 squared, which is just going to be equal to -1. Then I cubed will be, if we split this up, this will be I squared times I, which we already know that I squared is -1. So -1 times I will be -I. Then I to the fourth will be, if we split it up, I squared times I squared, which is -1 times -1. So this will be a positive 1. And this is kind of, if you keep going, this pattern repeats, but that's how to derive the pattern if you forget it during the test. So every fourth power of I, this pattern starts over. So you're kind of going to be looking for the highest multiple of 4 that goes into 55. And so that is going to be 52. So if we split this up, 52, I to the 52 is just going to be 1. But the remaining part is I cubed, or I to the third, which our I to the third is -I. So really, I to the 55th is just a -I. Then I to the 123rd can be broken down to I to the 120, so you're just finding the highest multiple of 4 that goes into 123 that will leave you with a remainder between 1 and 4, or 1 and 0, between 0 and 3. So then this will be -I as well. I to the 17th, this will be I to the 16th times I to the 1, which I to the 16th is just 1 because it's a fourth multiple. And then times I is just I, so this will be equal to I. And then just use your calculator to find what is the highest multiple that goes of 4 that goes into 5,321, and that is going to be I to the 5,320. So you will have 1 remaining, which is just I. If you do get something like I to the 20th, I to the 20th is already a multiple of 4, so that is equal to 1. Just to clarify that. And that is where I'm going to stop